In this question, we have Q1, Q2, and Q3, so 3 charges. And the first charge is at the origin. So let's just make this the origin here and say it's Q1. And then charge Q2 is on the x-axis at x equals 1 meter. So if we assume this is our positive x-axis, and say this is our 1 meter sign, and that would be Q2. So this is at 0 meters and this is at 1 meter. And then we have a Q3 which is located at x equals 0.75. So it's about 3/4 way in. So let's just put Q3 right here, and this would be 0.75 meters from the origin. So let's just look at the charges. So Q1 is negative, so I'm going to make this negative here. Q2 is negative because it says negative 2.2, and then Q3 is positive, so this is positive here. So the first thing we need to find out, because we need to find the net force acting on a charge Q3, so we care about Q3 and not about the other two so far. So I'm just gonna just draw a little box here. And now let's look at Q3 in terms of Q1 and Q2 and their forces, or which directions these forces act. So as you can see, Q3 is positive, Q1 is negative, which means they attract. Now, we don't care about what happens at Q1, we care about what happens at Q3. So because they attract, then you have a force this way, and let's just call it F3, 1, because F of Q3 because of Q1. And now let's look at Q2 and Q3. We see that it's also positive and negative, which means it's attractive. So at Q3, it's going to attract towards Q2. And let's just make it F2, 1. And you see that I didn't draw anything at Q1 or Q2. And that's not because there aren't forces acting there, it's just that that's not the question. So now what we can do is go ahead and find the magnitudes of F31 and F21, meaning that the number and not just the direction. So F31 here, our Coulomb's law equation is K, Q1, Q3 over R squared, and R is the distance between 3 and 1. And Q1 and Q3 are absolute value here. So for K, we can write 8.99 times 10 to the 9th Newton meters squared over C squared. And then Q1 is 5.4 times 10 to the negative 6 coulombs. And then Q3 would be 1.6 times 10 to the negative 6 coulombs. Note that I did not write negative for 5.4 because we are looking at absolute value. Now this all divided by R squared. R is the distance between Q1 and Q3 because we are looking at F31. So that is 0.75 meters squared. And if you solve this, this gives us about 0.3138 newtons. Force is a vector and it's in newtons. Now let's look at the magnitude of F32. So here it should be just the magnitude. So it is K, Q3, Q2 over R squared So we have 8.99 times 10 to the 9th. We have Q3. And then we have Q2, which is, again, this is absolute value, so we are only taking the positive. And then divided by the distance between 3 and 2. So what's the distance between Q3 and Q2? It is, so it's 0.75 and 1 meter. So the difference is 0.25 meters. If we solve this, it gives us 0.51 newtons. Now what's the net? So the net force on charge 3 is, if we take positive as our right hand side and negative as our left hand side, you see that F21 is to the right, and this should actually be F. So we have positive F32 and then negative F31. Because both these vectors are on the x-axis, we can just do it like this and not bother about the angles. So what we have is positive 5.1 and negative 0.138, and that gives us positive 37 newtons. And then that's the magnitude, and the direction is positive x.